Okay, so day 4 is all about definite integrals. What we had been doing so far is indefinite integrals, meaning if you look back to like day 1, day 2, day 3, we didn't have bounds here. And now we do. Okay, but that's nothing new. We've learned how to deal with bounds. So I'm going to put together what do you do with definite integrals and u substitution. Okay, there's just a little extra thing you need to do. But honestly, we could figure this out together so it's not a completely brand new topic. So first of all, looking at this example 1, how do you know this is a u substitution problem at all? You have something in parentheses that's kind of complicated to a power. All right, and so if you notice, that's what we're going to let u equal, and they have that right there. The du is wrong, and I always forget to fix this. Okay, what is du? 2x dx. So scratch that out and write this. And so we know to divide that 2 over and make a half. So the half goes out in front. And all of this you should be pretty comfortable with by now. This kind of goes back to day 1. All right, now the newer stuff was, well, I don't say, even back to day 1, it was using x and dx. Okay, see how there's an x and a dx? What if the x had been missing from this box over here? I would have to do, yeah, which I kind of nicknamed Toko, that other kind of, and that was yesterday. This is not a Toko problem. This, though, is a pretty normal problem. All right, so if I'm just putting in u cubed, and then I replace the x and the dx, I take those out and I replace it with 1/2 du. Okay, this is all stuff we've already done. Here's the new part. We have these bounds, 1 and 0. These are x values. Okay, so we have this down here. If x equals 1 and u equals x squared plus 1, then the upper bound is 2. Think of it like this. 1 squared plus 1. All right, and these are now going to be the u values. If x equals 0, what's 0 squared plus 1? 1. So those are going to be my 2 new bounds. In terms of u, my bounds are 1 and 2. That's the difference. Okay, that's the only new thing today. All right, so let's go ahead and finish out this example. So they're asking us to now evaluate the definite integral. So we have our 1/2, and we are ready to integrate. I don't need to simplify or anything. So remember, put a parenthesis or bracket to show that you're not integrating anymore, that what you're about to write is the antiderivative. So what is the antiderivative of u cubed? 1/4 u to the 4th. And then we would write the bar and then write our bounds. This signifies that I have integrated, but I still need to plug in my bounds. Okay, now I do want to kind of make a point to say something here. When we've been doing u substitution, at this point is when we would have replaced u with x squared plus 1. We don't have to do that here because I have bounds. I can do that, but if you replace u with x squared plus 1, you got to go back to your original bounds, and it's like you're just doing extra work for no good reason. Okay, also, why did I not write the plus c here? When you work it out with numbers, it ends up canceling out. Okay, so let's go ahead and plug the numbers in. 1/2, and then I would go ahead and do 1/4 and plug in 2 first, minus parenthesis, and then 1/4, plug in 1. That's our answer. It is unsimplified, but it is our answer. Okay, so the nice thing about definite integrals, even though you have to plug the numbers in and figure out what the new numbers should be, you don't have to rewrite it with the x, at least. All right, that's totally right. What if this was multiple choice and they wanted you to, and then the answers were all simplified? Okay, I want you guys, just for this one, this is the only one I'm going to make you do this on, simplify this without a calculator. There's some M&Ms for whoever gets it first. No calculator. What you got?
15. Oh, wait.
Wait.
If you know it, shout it out.
I didn't have it.
Can I use a fraction?
15.
Yeah. Well, now y'all are all giving it at the same time.
15/8.
Is that what you were going to say, Brody?
Pretty much.
Okay, y'all three.
Who?
Tim, Brody, Natalie, y'all all pretty much said it at the same time. Go get the splits of it. Well, you did. Good job. And I think technically you were first. You were just, they got in on you.
Partial math, please.
Okay. So that was just for fun. Wake everybody up. This does turn out to be 15/8. You don't have to simplify it, guys. Remember, you don't have to do this. Don't waste time doing this on a test unless it's multiple choice, in which case you have to figure that out. Okay, let's move on to the next example. So I've been kind of telling you that for now, I'm going to tell you when it's TOCO because I just introduced it this week and we have a test this week. But I want you to be thinking every time, how do I know this is a TOCO? Next time, next week, she's not going to tell us. We have to figure it out. So let's look at this problem as if we didn't know it was a TOCO. Okay, first of all, what I want to do is just rewrite it and only change one slight thing. And that is, I want to put the 2x minus 1 in parentheses, which would, what would the power be then? Negative 1/2. 1/2 because of the square root, negative because the denominator. So once you write it this way, figuring out what u equals should be pretty easy. It's the thing in parentheses. So u is 2x minus 1. Okay, so immediately we figure out what du equals, which would be 2 dx. Okay, move that 2, divide it over, and that's going to go in front of the integration symbol. And if you notice, there's a dx that I'm going to replace with a 1/2 du, but there's an extra x. That's how you know this is a TOCO problem, because this x is extra. It's not part of the x dx. You know, that'd be nice if this was x dx. It would work out nicely, but it's extra. Okay, so what am I going to replace this x with? Well, we got to do a little bit of work to figure that out. But if u equals 2x plus 1, then that makes 2x equal to u plus 1. So what would just x equal? Yeah. Yeah, and the way we kind of wrote this yesterday, and this is just a preference, I think for a lot of people it makes it easier to think of it like that. So in place of x, I'm going to write that 1/2 u plus 1/2. In place of 2x minus 1, I'm going to write the u. So that would be u to the negative 1/2. In place of dx, I'm going to write 1/2 du, and the 1/2, we already wrote that at the front. Okay, all of that is like what we did new yesterday. Okay, so what's new today? The bounds. This 1 and 5, these are x values. We want to change them into u values. So use that. What is the 5 going to change into? If you go 2 times 5 minus 1, 9. Okay, 2 times 5 is 10, minus 1 is 9. That's going to be your upper bound. What is the 1 going to change into? Yeah, it kind of just ends up staying 1. 2 times 1 minus 1 is still 1. Okay, the best part about today is that depending upon the directions, this may be all you need to know how to do. So I want you to turn the page really quick, and I want you to look at number 3, and more specifically, look at the directions above number 3. It says, given the following integrals, define u, then indicate what the new integral would be in terms of u, with the change of bounds. Okay, if that's what your directions are, then you're done. Let me come back to where we were at. Do you see what I'm saying? We did that. We defined u, we wrote the integral in terms of u, we changed our bounds. So, on the homework for tonight, You don't have to go through all the steps on most of the problems. Most of the time you're going to get to stop right here. Now, I do think we need the practice, and sometimes we do have to complete it, so let's do that on this one. All right, but just know that depending upon the directions, you could stop right there. Before we integrate, if you remember from yesterday, we got to distribute. You got to simplify. Okay, so the way we did that is we had a 1/2, we had a u. We had u to the 1 times u to the negative 1/2, so we added those two powers. I'm not integrating, I'm just using exponent rules. Okay, it's just like when you have x squared times x cubed. That's x to the 5th. You add the two exponents. That's what I'm doing here. I'm distributing and I'm adding, it's like 1/2 u to the 1 times u to the negative 1/2. I added 1 and negative half to get a half. Okay, now I'm going to distribute this. I have positive half times u to the negative 1/2. So I distributed, in that one step I distributed. Once you do that, you're ready to integrate. Okay, it's about to get really messy, but it's okay. I know some of you are like, about to. Okay. Before I go on, does anybody have any questions, or do you want me to go back? So this 5 up here, the question is, how did 5 turn into 9? This is x equals 5, right? Because these are all x's. But in this line, I'm not using x's anymore. I'm using u's, right? Okay, so I'm going to go back to, we said that u is equal to 2x minus 1. So if x is 5, what is u? Like, you can get this. Everybody, I mean, and I know other people have it. Think of it almost like this. You just plug it in. If x is 5, I want to know what the u is, so I'm going to go 2 times 5 minus 1, and that gives me a 9. So when x is 5, u is 9. So when we translate this into u, we got to change the bounds into those new u values as well. Does that make sense? We haven't done this before today because we haven't had bounds in any of those problems. And you do the same thing with the 1. Okay, any other questions? That's a good one. Okay, so let's continue on with this problem. All right, 1/2. Let's put a parenthesis or bracket because we're ready to integrate here. I'm going to make this a little bit bigger. All right, so how do we integrate? And if you're like, oh, there's so many parts of this problem, you're right. So let's just focus on one part, integrating this part right here. The coefficient to this part is 1/2, so I'm going to go 1/2 over something. The new power on u when I integrate is I get that by adding 1. 1/2 plus 1 is 3/2, and that's what we put right down there as well. Don't worry about how gross it is. We're just writing it, not simplifying it. Okay, right here I have 1/2 over something. U, what would be the new power on this term? 1/2. If you have negative half and you add 1, you get 1/2. That goes right down there as well. Again, I have bounds, so I don't need the plus c. I just need to do the bar, 9, and then a 1. After you integrate, if you have bounds, this bar signifies what numbers you're going to plug in. But I wouldn't want to write the integral symbol anymore because I already integrated. All right, I'm going to change the thickness of this a little bit. Okay. So, even if someone just walked in and hadn't even seen this problem, they can do the next step. All right, we have a half. You can simplify if you want to, but like why? Okay, it's fine if you do. which of these two numbers am I going to plug in for you first? The top number, 9. Okay. I'm combining a lot of things in this one problem, and it really doesn't get worse than this, if that makes anybody feel better. Okay, after you plug in the top number, what symbol are you going to put next? Minus parenthesis. Now we plug in the lower bound. So now we're going to plug 1 in for you. Is this gross? Yep. It's pretty gross. I'm going to erase this. What if I had what?
All your students
Color coded?
And what if you had all your students make it color coded so they could grade?
I don't know.
I'm just talking to myself. No one's listening.
It's,
Well, you asked us to listen when you.
I don't
all right.
to laugh at us.
Here is, it's okay. Here is, we all love each other. Here is the final answer. This actually could be simplified. I just want you guys to just take the anxiety down a notch. Why could this be simplified? Not too bad.
Because it's all 3s and 9s and 1s.
Yeah, 9 and 1. Can you square root those numbers evenly? Yes. Okay, what's 1/2 over 1/2? That cancels. I'm not going to make you do this even for M&Ms, but if you want to do it just for fun, be my guest. Okay, so that's the final answer. I already told you this, but let me remind you of something I said a few minutes ago. Let me change the zoom here. And that is, if the directions say, I mean, because this is a big deal. Some of you are going to do this on tonight's homework because you don't read the directions. If the directions say just to write it in terms of you, then you stop right there. And that's what the directions are going to be most of the time. Okay? So it's going to be really rare that you got to go through every step in here. Okay? And this one was obviously harder than the first one because it was a TOCO. This combines everything. All right, let's look at example 3 because some of you are thinking, well, what if it's multiple choice? I'm going to have to simplify then. Well, not necessarily, because if you look at this example 3, forget about these for a second, okay? If you try to do this in your head, you're going to make a common mistake and pick the wrong thing. But just looking at this integral right here, what are you going to let u equal? X squared plus 1. Everybody should be really comfortable with this by today. If you're not, I can help you with that, explain it a different way, but that's where we should all be. We also should all be able to do the du statement. In this case, the derivative would be 2x, and then don't forget your dx. What do we do with the 2? As always, we divide it to the other side. So I'm not even looking at these answer choices yet. I'm going to go ahead and write a 1/2 and an integral symbol. You can kind of sort of tell probably what the answer is going to be, or at least narrow it down, but we're going to keep going. Because when we try to do stuff in our head, that's when you're going to get these wrong. All right, now, there is an x and a dx right here, and there is an x and a dx right there. It matches up perfectly. This is not TOCO. Okay? All we got to do is replace that u, replace the x squared plus 1 with the u, and then replace the dx dx with a 1/2 du. So the answer is A, right?
No.
Not necessarily. What was the whole lesson today about? The bounds. Right now, my upper bound is B and my lower bound is A, but those are X values. They're letters, but don't let that throw you. You've got to change the bounds using this statement. Right now, it says X equals B. If X equals B, then what does U equal? b squared plus 1. Now in the problem we did a few minutes ago, that was something we actually computed and did the arithmetic. Well, b squared plus 1, that just remains b squared plus 1.
Confused how X is B.
Okay, these right here, these are x values.
Okay.
Like, we don't write x equals b, but we might as well write it, because what the bounds mean, let me just kind of draw a picture. Like, if you have a curve and you have a and you have b,
Okay.
that's you're finding the area trapped between the curve and the x-axis between x equals a and x equals b. So that's why I wrote it that way.
I understand.
Yeah, good question. So then the bottom bound would be a squared plus 1. Okay, so what's the answer? C. Okay, so some of these are easier than even what we were doing yesterday or before. Alignment.